Hello, my mathematicians. Today we are looking at Module 7, Lesson 3, Assessing Reasonableness of Mixed Number Sums and Differences. Hopefully by the end of this lesson, you'll be able to add and subtract mixed numbers with unlike denominators and assess reasonableness. So if we look at number 1, it says, Caroline trains every weekday or weekend for a track and field competition. She writes down how long she spends running sprints and jumping hurdles. How many hours does she spend training on Sunday? So it says, asks us to start by writing an expression to model the situation. Well, if we look over on the side, we see her problem or what she did. So sprints were 2 2/5 hours. And we would add that to the 1 1/4 hours that she did for hurdles. Now we want to estimate that answer. So we ask ourselves, is 2 2/5 closer to 2, 2.5, or 3? Well, I know that half of 5 is 2.5, and so that 2/5 is going to be close to half, so it's going to be closer to 2.5. And 1 1/4 is in the middle, can go either way, but I'm going to make it as easy as possible for myself and make it closest to 1. So we have 3.5 as our estimate. So C says rewrite the expression in part A using equivalent fractions with a common denominator, then find the sum. So our first step is to find a common denominator. So that means I need to list out my multiples. So of 5, we have 5, 10, 15, 20. For 4, we have 4, 8, 12, 16, 20. So that means my common denominator is going to be 20. Now I need to write my equivalent fractions. So we have 2 2/5 is going to equal 2 and something over 20. What do we multiply 5 by in order to get 20? Well, we multiply it by 4. So 2 times 4 is 8. And then we have 1 1/4 equals 1 and something over 20. What do we multiply 4 by in order to get 20? Well, it's 5. So we have to do 1 times 5, which is 5. So we get the expression 2 8/20 plus 1 5/20. So you see, up to this point, I wrote down what my whole numbers were, but I kind of ignore them. They don't change anything. So I go to actually add or subtract. So next, I would then want to solve this. So I have 8/20 and 5/20. So the 8 plus 5 is going to be 13. And the denominator is the same. And then I'm going to add my whole numbers. 2 plus 1 is 3. So I get 3 and 13/20. So how many hours does Caroline spend training on Sunday? That would be 3 and 13/20 hours. So is our answer reasonable? And I'm going to say yes, because 3 and 13/20 is close to the estimate of 3.5. And then we're going to turn to the next page. Says Jonah's best pole vault jump is 7 1/4 feet. A sign in the gymnasium shows the gym's record. How much shorter than the gym's record is Jonah's best jump? Write an expression to model the situation. We have 8 and 7/12. And we want to know how much shorter, so we're subtracting. Or how much more he has to go, sorry. 7 and 1/4. Estimating the answer. Well, 8 and 7/12 is close to 8.5. And 7 1/4, again, the 1/4 could go either way, but we're going to make it easy and just make it 7. So my half is going to stay, and 8 minus 7 is 1. So 1.5. So now we need to rewrite the expression in part A using equivalent fractions of the common denominator. So my first step is to list out my multiples. So my multiples of 12, 24, 36. My multiples of 4, 8, 12, 16, 20. Well, they both have 12. So then I write my equivalent fractions. 8 and 7/12 is going to equal 8 and 7/12 because we're not changing the denominator. And then 7 and 1/4 is going to equal 7 and something over 12. We multiply the 4 by 3. Whatever we do to the denominator, we need to do to the numerator. So 1 times 3 is 3. So we're going to have 8 and 7/12 minus 7 and 3/12. So if we want to set that up so it's a little easier to see what we're doing, we subtract our fraction first. So 7/12 minus 3/12 is going to be 4/12, and then 8 minus 7 is 1. So 1 and 4/12 feet. And we'll say, yes, it's reasonable because one and 4/12 is close to 1.5. And that is it for today's lesson. Hopefully you are now able to add and subtract mixed numbers with unlike denominators and assess reasonableness. Remember, in order to be a math person, all you have to do is be a person and do math.